lesson, section R3, we're going to factor. But first of all, we're going to factor by grouping, and this is how I typically factor trinomials. If you've learned another way, then you're welcome to use your method. But this of course isn't a trinomial, but it's an example of how we factor by grouping. So to factor by grouping, what we do is we take our expression and we say we group the first two terms and group the last two terms. Okay? And when we do that, we're going to factor out of each group. So factor out of each set of parentheses. So 7CD minus C squared. What factor out? A C will. And then we're left, if we take out one C from each term, then we're left with 7D minus C. What will factor out of 14D minus 2C? A 2 will factor out. So if we factor out a 2, 14D divided by 2, we're left with 7D. And 2C divided by 2, we're left with just C. Now, what is the advantage to this? Now, this doesn't always work when factoring more than a trinomial, but if this works out like we want it to, then what we end up with is we've got in our parentheses, after we've factored from our groups, identical binomials. And if we have identical binomials, we can actually factor them out. So if we take this, if we've got this term, and we take the 7D minus C out, then we've got 7D minus C, and we're taking it out of both this term and this term. So what are you left with? C plus 2. So this is an example of factoring by grouping, which is what we will use with our trinomials here in a little bit. So factoring trinomials. The first one here is a trinomial with a leading coefficient of 1. Basically what that means is there is a 1 in front of this x squared. There's not another number in front of the x squared. And so what we're looking at here is factoring x squared minus ax plus 12. Okay? So, since there is just a leading coefficient of 1, then we don't need to factor by grouping. You can, but you don't need to. So what we're going to do is we're going to ask ourselves, what will multiply to give us 12 that will add to give us negative 8? And notice we're looking at the negative with the 8. What will multiply to give us 12 that will add to give us negative 8? And so some people will make a little table over here. What's something that will multiply that gives you 12? Well, 3 times 4. 3 times 4 adds to be 7. So this one isn't going to work. So we try something else. What will multiply to give you 12? 6 times 2. 6 plus 2 gives you 8. Well, that's not quite. Wait a minute. Okay, so that's not quite there because we've got a positive 8. So that's not going to work, but we're closer. What if we do negative 6 times negative 2? That'll multiply to give us a positive 12, right? And if we take negative 6 plus negative 2, that gives us negative 8. So those are the numbers that we're going to use. Negative 6 and negative 2. And so our answer here is x minus 6 times x minus 2. Okay, so that's how we factor a trinomial with a leading coefficient of 1. And you'll see why we get the parentheses and everything when we factor more by grouping here in a minute. If you want to look at this, why does this work? Well, if we go back and FOIL it, then we'd have the first is x times x, that's x squared. Outer is x times negative 2, so negative 2x. Inner, we get negative 6x. Last, we have negative 6 times negative 2, that's positive 12. Combine our like terms, and we have x squared minus 8x plus 12. So you can always check your work by foiling to make sure you've factored correctly. Okay, so let's get into the nitty-gritty here. Let's look at an example where we have to factor with a leading coefficient that is not 1. So what we do with this is we take our leading coefficient and our last value there, okay? And we're going to multiply those. So 3 times negative 7 is negative 21. And so what we ask ourselves in this case is, what will multiply to give us negative 21 that will add still to give us the number in the middle, negative 20. Okay? So we look at some options. We've got negative 3 times 7. Well, negative 3 plus 7 is 4. So that's not going to work. If we look at this carefully, you probably see that the best bet is going to be something like 1 and negative 21. 1 times negative 21 is negative 21. And 1 plus negative 21 is negative 20. So that means that the numbers that we're going to use are 1 and negative 21. So what do we do with that? So our original expression is 3x squared minus 20x minus 7. What we're going to do is we're putting that 1 and negative 21 in the place of the negative 20x. So bring down 3x squared. And in the place of negative 20x, we're going to put positive 1x minus 21x. Notice our 1 and negative 21. And then we bring down our negative 7. This gives us the opportunity to group. So now we're going to do our factoring by grouping. Out of the first pair, we can bring out, we've got 3x squared plus 1x. We can bring out an x. Then we'll be left with 3x plus 1. Out of the second pair, we can bring out a 7. So we've got 21 divided by 7. That gives us a 3x. And then we're taking the negative 7 out of negative 7. That leaves us with plus 1. Notice if we multiply this back through, we would still get negative 21 plus, or excuse me, negative 21 minus 7. Okay? So we've got now our two binomials that are identical, and just like in the first example, we factor them out. So 3x plus 1, and we're left with x minus 7. And that is 3x squared minus 20x minus 7 factored. Let's do check this. I'm not going to check it every time, but for this first one, if we check it, we've got 3x times x by FOILing. We've got 3x squared, and then we've got 3x times negative 7 is negative 21x. 1 times x is positive 1x, and 1 times negative 7 is negative 7. Combine the like terms, and we get our original trinomial. Excuse me. So it does check out. Let's look at some more examples of this. So, same thing again this time. We've got 6 times 5. That's 30. So we're going to ask ourselves what multiplies to give us 30 that adds to give us the number in the middle, 13. And you can probably see pretty quickly, 3 times 10 gives you 30. 3 plus 10 gives you 13. So that works out. So our numbers are 3 and 10. So again, take your original trinomial, and we're putting in the 3 and the 10 for the 13. So we've got, bring down the 6x squared. Then we've got plus 3x plus 10x. That gives us 13x. And then bring down the plus 5. This is where we group and factor out. So factor out of the first pair. We can factor out a 3 and an x. And so we're left with 2x. If you factor 3 out of x out of 3x, you're left with 1. And yes, you have to put that plus 1 there to fill the place. And then out of 10x plus 5, we can bring out a 5. And we're left with 2x plus 1. Check again that those two binomials are the same. If they're not, you've done something wrong, or it doesn't factor. So we're bringing out the 2x plus 1, and we're left with 3x plus 5. Next example. Now this example, you're looking at it and you're like, oh my gosh, these are huge numbers. If we multiply, it's going to be crazy. Well, the nice thing about this is that we could factor out something first that will help get our numbers smaller. So what we can do is we've got 10, 105, and 55. What could factor out of all of those? A 5. So if we factor out a 5, then we're left, oh, oops, there's something else. We've got x cubed, x squared, and x. So an x can also factor out. So we're factoring out a 5x. That leaves us with 2x squared plus 105 divided by 5 is 21. So 21x minus, and 55 divided by 5 is 11. So notice that gets the numbers in our trinomial smaller. We're going to keep that 5x with us as we go. It's important to be in the end of your, and to be in your answer. But we're pretty much going to ignore it until the end. So now we've got 2x squared plus 21x minus 11. So just like with the last, we take 2 times negative 11. That gives us negative 22. And we go over and create our little table. What multiplies to give us negative 22? That adds to give us the number in the middle, which the number in the middle is now 21. Okay? So you could guess 2 times 11. That's not going to work. I can see here then what we're going to need is negative 1 times 22. And if you have to go through some guessing, that's perfectly fine. But in this case, negative 1 times 22 will give us negative 22, and negative 1 plus 22 will give us a positive 21. So our numbers that we're going to use are negative 1 and positive 22. So when we come over here, we're going to keep our 5x. Just going to tag along with us. And then bring down the 2x squared. Inside here, in place of the positive 21x, we're going to put negative 1x plus 22x. And then bring down the minus 11. Again, just bring down the 5x, and we're going to group inside our parentheses here. And in the first pair, 2x squared minus 1x, and x can come out. And we're left with 2x minus 1. In the second pair, an 11, it's 22x minus 11, and 11 can come out. Oh, I need to have a plus 11 there. And so that leaves us again with 2x minus 1. And then we've got our other parenthesis there. Notice our binomials here are the same. And so we can factor out our 2x minus 1. And then we have times x plus 11. And on the outside, don't forget your 5x. And so that's how we would do that. If you can factor out something in the beginning, that's the easiest thing to do. Otherwise, you're going to end up with really big numbers that'll make it really difficult. Okay, some tricks. Perfect square trinomials. A perfect square trinomial is when you happen to have the first term being a perfect square, like 4, 9, 25, 36, and the last term being a perfect square. And we happen to have that the middle term is 2 times the square root of both of those. So let's just say, for a quick example, if we had 4a squared, and over here we had 25, okay, then in the middle we would have to have the square root of 4, which is 2, and the square root of 5, which is 5. So 2 times 5. So that would be 20a in the middle. That's what we would have to have have a perfect square trinomial. And that also works with subtraction. If you're subtracting in the minus 2ab, then you end up with a binomial squared over here. The b squared still has to be positive. So looking at an example, how do we know if this is a perfect square trinomial? Well, first of all, if you recognize you've got a perfect square here and you've got a perfect square here, well, let's look and see if that number in the middle is 2 times the square root of the first term times the square root of the last term. If it is, then we've got a perfect square trinomial. So 2 times 2 times 7, that's 4 times 7, which is 28. So yes, we have a perfect square trinomial. That means, since this is a minus here, that we have square root of 4, which is 2, the square root of 4x, which is 2x, minus square root of 49, which is 7, quantity squared. Realize that this is the same thing as 2x minus 7 times 2x minus 7, which if you were to FOIL would give you 4x squared minus 28x plus 48. Okay, but we keep it as the 2x minus 7 quantity squared because that's simplified. Let's look at another one. Again, we can recognize that 81 is a perfect square and 25 is a perfect square. So we look and see, does the number in the middle, 90, is that equal to 2 times the square root of 81 times the square root of 25? Well, that's 2 times 9 times 5. So 2 times 9 is 18, and 18 times 5, let's just double check this to make sure, yep, it's 90. So it is a perfect square trinomial. Since this is a plus here, then we'll say the square root of 81x squared is 9x plus, and then the square root of 25 is 5, quantity squared. Another shortcut is the difference of squares. Okay, so let's say you've got a perfect square minus a perfect square. And this only works in this case. It does not work if you have a perfect square plus a perfect square. Okay? So if you have a perfect square minus a perfect square, then that factors to be the square root of a plus the square root of b times the square root of a, well, excuse me, let's say the square root of the a squared plus the square root of the b squared. So we've got a plus b, and then it's times a minus b. Okay? So if you've got a difference of squares, a square minus a square, then that gives you the square root of those as a plus b times a minus b. Okay, so in this case, yes, we have a difference of squares. How do we know? X squared, the square root of x squared is x. The square root of 100 is 10. And there is a minus in the middle. So that means that very quickly our answer is x plus 10 times x minus 10. And that's it. let's fold these back through just to look and see what happens, okay? You don't have to write this down. We'd get x squared plus 10x minus 10x minus 100. Notice you've got a positive 10x and a negative 10x. That makes it go away. And so you're left with x squared minus 100. That's why difference of squares, the rule works. Oh. So, factor this. Okay, we've got a binomial. We know it's not a trinomial. We can't do any kind of factoring by grouping. The only other things that we've learned is how to factor out a number from each, or a number and a variable from each term, or the difference of squares. Well, this isn't a difference of squares as it stands, because 32 is not a perfect square. 162 is not a perfect square. So let's see if we can factor something out of these two numbers. We can factor out at least a 2. So let's see. If we factor out a 2, then we're left with 16x squared minus 81. Now, guess what? We have a difference of squares. So, keep the 2, and we've got 4x plus 9 times 4x minus 9. Okay. Okay, sum and difference of cubes. With cubes, you can have a plus in the middle, okay? So, if you need to factor a sum of cubes, so a cubed plus b cubed, then that is a plus b. So, your cubed root here and your cubed root here, times, and then we've got this trinomial here, a squared minus a times b plus b squared. Then with a difference of cubes, then we have a minus b times a squared plus ab plus b squared. So let's look at an example. Here we have a sum of cubes. You know this because hopefully these will be fairly obvious when you look at them, because we can take the cubed root of x cubed. And so if you see an x cubed in your problem, then go ahead and check to see if it's a sum or difference of cubes, okay? And the cubed root of 125 is 5. 5 times 5 times 5 is 125. So this will work as a sum of cubes. So we have the cubed root of x cubed, that's x, plus the cubed root of 125, that's 5, times, let's look back just to make sure I get this right. So we'll have the first, let's see, x squared minus, and then we've got a times b. So x times 5, or 5x, plus 5 cubed, or excuse me, 5 squared. And 5 squared is 25. Now you need to look at this before you end here and make sure that you can't factor that trinomial there. Is there anything that'll multiply to give us 25 that'll add to give us negative 5? No. So we're good to go. That's as far as you can go. Look at this one. This time, we also have a difference of cubes. And yes, x to the 6 is a cube. So, in this case, let's look at it here. The cubed root of 8x to the 6th would be, let's just go ahead and write this out to make sure we understand why this is a cube root. So we would have 2 times 2 times 2, and then x times x times x times x times x times x. Okay? Remember groups of 3. So you have a group of 3 here, we have a group of 3 here, and we have a group of 3 here. And so out comes the 2 and an x and another x. So that leaves us with 2x squared. So the cubed root of 8x to the 6th is 2x squared. Let's make sure that 27y cubed is a perfect cube. That would be, I forgot my 3 up here, sorry about that. The cubed root of 3 times 3 times 3 times y times y times y. So you've got your groups of 3 again. So the cubed root of 27y cubed is 3y. So this is a difference of cubes. So you always want to go out to the side and check and make sure. So what we can say then is 2x squared minus 3y. And then over here, I'm going to double check this. Yes, it's pluses. Just want to make sure. So we have 2x squared squared plus 2x squared times 3y plus 3y squared. And then we simplify that. So we've got this, and then 2x squared squared, well, you got to square the 2, so 2 squared is 4, x squared squared, that's x to the 2 times 2, x to the 4th. Then we've got 2 times 3 is 6, x squared times y is just x squared y. And then 3 squared is 9, and y squared. Okay? So that is that factored. Will this factor? Let's see. Is it a perfect square trinomial? You'd have 2 and 3. Nope, it's not. So this one won't factor. Okay, so we are finished with that. Simplified. Okay, so these are just some techniques you would use. We've already gone through these, but they're listed here all together, what you would do in each case. Okay, so if you've got 4 or more terms, you would try factor them by grouping. If you've got 3 terms, then you've got look and see if it's a perfect square trinomial. If not, it says factor by the trial and error method. Yeah, if it's got a leading coefficient of 1. If not, I do what we did and end up factoring by grouping when we have 4 terms. If there's two terms, is it a difference of squares, a sum of cubes, or a difference of cubes? So let's look at a nice large one here. Okay, there are 4 terms. So according to our list here, we need to start factoring by grouping. So I'm going to group the first 2 and the last 2. You can always rearrange, but I don't think we need to in this case. So in this case, in the first pair of terms, we can bring out an x cubed. We're left with x squared minus 9. In the second pair of terms, we can bring out an 8. And we're left with x squared minus 9. Oh, I meant to write that in a color. Let's change that to a color. There we go. Okay, so you can see here that our little binomials there are the same. And so we can bring them out. X squared minus 9. And then we've got x cubed plus 8. Now you would like to say that you could stop here. But you want to look and see what you've got. And see if there's anything else you can do with it. Look at the x squared minus 9. We have a difference of squares. See here, 2 terms, it's a difference of squares. So, if x squared minus 9 is a difference of squares, then that's going to give us x plus 3 times x minus 3. Now, check out the x cubed plus 8. Is that a difference of squares? No. Is that a sum or difference of cubes? Yes, because 8 is 2 cubed. So we can factor this even more. Since the cubed root of 8 is 2, then we can say, and the cubed root of x cubed is x, we can say x plus 2 times x squared minus, notice here, if we've got a plus here, then we've got to put a minus over there. So minus x times 2, or 2x, plus our cubed root of 8, which was 2. Now, let's see, x plus 3 can't be factored anymore. Neither can x minus 3 or x plus 2. Is there anything that'll multiply to give us 2, that'll add to give us negative 2? No, we are done. And last example. Again, we've got 4 terms. So we're going to look at factoring by grouping again. And I'm sure there's going to be plenty more we can do with it, huh? So let's see. Let's see. First, we have, I think, we've got, give me 1 second. I'm trying to think of what we should do with this. Because there's not anything we can take out of the first pair. There is out of the second. But I'm seeing a perfect square trinomial there. Let's see, we've got gosh, I'm not sure what it wants us to do with this. Bear with me. Just 1 minute, please. I apologize. I see a couple options that we can go through, but I want to make sure we do it the way the book wants us to do it. Okay, so, okay, I was right. Okay, so here's what we want to do. I recognize that there is what appears to be a perfect square trinomial there. Okay, but it's not quite a perfect square trinomial because of the minus minus. So what we're going to do is we need that to be in parentheses, and if we do that, then we're factoring out a -1. So we end up with a positive x squared there. We're factoring out a -1, so we have a positive 4xy and a positive 4y squared. Now we have a perfect square trinomial. So we've got 25 minus x plus the square root of 4y squared is 2y, quantity squared. Okay, now that's all fine and dandy, and it looks like we might not can go any further, but guess what? We can. This is a difference of squares because we've got that a perfect square, 25, and a perfect square, x plus 2y. So, guess what? This gives us, I'm going to use brackets, so this is easier to follow, 5 plus x plus 2y times 5 minus x plus 2y. Okay, because that was a difference of squares. Now, let's just rewrite this, and we've got, get rid of our parentheses in there, so we've got 5 plus x plus 2y times 5 minus x, distributing that negative there, don't forget that, minus 2y. And now, that's as far as we can go. Did that